Hi, in the last video we talked about the two independent samples and how to conduct the hypothesis testing when we are given two independent samples. In this section we focus on two dependent samples or the mass pairs and to conduct the claim for that. Okay, so just a quick recall. Independent samples are the samples that when you pick something for one sample and then you pick another data for the other sample, they are not related to anything. So picking one value for one sample doesn't affect your choice of picking another value of the other sample. However, for the dependent samples or the mass pairs, if the sample values are somehow matched, then if you pick one value for one sample, then the other value for the other sample it has to depend on the first sample that you pick. And we normally use the pair samples for case control studies, or if you want to repeat the measurements of something. For example, suppose you are interested in evaluating the effectiveness of a company's weight loss program, then one approach you may consider would be to measure the weight of a sample of the employees before and then after the program completes. We do the measurement again, and then we analyze the differences between the pair samples. That means we measure the samples before and then after the program completes, and then we do the analysis for the pair samples because they are related. So this is dependent samples, and there's a few notations we use in this section. The letter D stands for the difference between the two values in a single matched pair. So just take the subtraction between them to find the difference between the two sample data, and that should be the individual difference between the two values. Mu D is the mean value of the different D. So D is again the difference between the data points, and mu represents for the mean. So this is the mean for the different D for the population of all the matched pairs of the data. The D with the bar is the mean value of the differences D for the pair sample data. Okay, and SD is the standard deviation of the differences D for the pair sample data. This is the standard deviation of this D, and it's just the number of the pairs of the sample data. Alright, so those are the notations we are using for these sections. And before you perform the hypothesis testing, make sure we check the requirements. The sample data must be dependent on the matched pairs. The samples are simple random samples. Okay, simple random sample. This is the requirements for all the hypothesis testing. And then the last one is that the number of the pairs of the sample data is large. Make sure that we have at least 30 of the pairs, or if you have less than 30, then you have to check that, make sure that the pairs of values have differences that are from a population having a normally distributed data. Okay, the normal curve if you don't have over 30 samples. Alright, so let's try to conduct the testing. Again, normally we have two ways, the p-value methods and the critical value methods, but we focus more on the p-value because this is a common method. All the technology nowadays they display the p-value, especially the TI-83 or 84 plus. When you do the testing, the program will display the p-value for the p-value methods. Now, before doing any of the testing, make sure we determine the correct null and alternative hypothesis. And there's always three cases: the two tails, the left tail, or the right tail. For the null hypothesis, we assume that the mu of the difference, or the mean of the differences d, they are 0. Okay, so here, they are all 0. So we assume that mu d, or the mean value of the differences d, to be 0. So again, the null hypothesis is always involving the equality, the equal sign. And then if they are not 0, then there are three cases. They are different, or less than, or greater than 0. The different side means the two tails. The less than side means the left tail, or the greater than side is meant for the right tail. Remember, pointing to the left, the arrow is the left tail. Pointing to the right is the right tail. And after that, you select a level of significant alpha, and this is the probability of making the type 1 error. And after that, we compute the test statistics. Okay, so the test statistic, it is different for the dependent and independent samples. So make sure that we use the correct test statistic. In the last sections, for independent samples, the test statistic we use to compute the T0 is this formula, but in this section, it is just this formula. This is the d bar. D bar is the mean value of the differences. So after you find all the differences between the two values in a single match pair, then we take the mean of these values to get d bar, and that is the d bar here. Divide by SD. This is the sample standard deviation of the differences for the d, and divide by the square root of n. N is the number of pairs of the sample data. And then we can use the table A3 or technology to find the p-value. The table A3 is from the formula tables by Mario Joyola. You can find the table A3 here. Right here. This is for the t distribution, so table A3. You can find that here. Or you can just use the TI-83 or 84 with the commands tcdf. And this commands take three inputs: the lower bound, the upper bound, and the degree of freedoms. And which we have n pairs, n number of pairs. So you just take the n-1 for the degree of freedom, df. So there are three cases. For the two tails, again, we find one tail, one area. We double it to find the sum of the area in the tails for the p-value. And for the left tail, we just focus on the left area. And for the right tail, we focus on the right area. And if the p-value is less than the alpha, we reject the null hypothesis. If the p-value is greater than the alpha, we do not reject the null hypothesis. And the same ways we, as in the last few sections, we also have the critical value methods. Now, instead of finding the p-value, we can find the critical value. And once you find the critical value, you can check whether the test statistic is inside the critical region or not. If the test statistic is inside the critical region, then we reject the null hypothesis. Okay, so let's consider this example. The following data represent the cost of a one-night stay in the Hampton, the hotels, and La Quinta for a random sample of 10 cities. 10 cities. Okay, you have this city 1, 2, 3, 4, 5, 10. They want you to test the claim that the Hamptons, the hotel of Hamptons, are priced differently than the Quinta hotels at the level of significant alpha equals 0.05. So they just want you to test the claim that the price they are different. Okay, so difference mean the two tails, right? Okay, so go back here. The question is, why are these match pairs data? Why are these data the match pairs? Now, because the hotel prices come from the same 10 cities, that means they are match pair. They come from the same 10 cities, right? Otherwise, if you pick the prices for the Hamptons in these 10 cities, and then you pick the prices for La Quinta in another different 10 cities, then that would be independent sample. But in this case, we focus on the 10 cities for each of the hotels branch here. So they depend on the same cities. That means they are the match pair. So because the prices come from the same 10 cities. Now let's do the requirement check before we can use the T statistic. The sample data are dependent. Yes, they are dependent. The sample data are random, semi-random sample. Yes, because we randomly collect the data. Okay, and the number of the pairs of a sample is large over 30. In this case, we only have 10. So the first requirement fails, or this is the small sample size. Now you must check this requirements. The pairs of values have differences that are from a population having a distribution that is approximately normal. Okay, so make sure we check the differences between the data and make sure that they are coming from a normally distributed populations. Okay, so we have the prices for the Hampton and the Quinta. The letter D is the individual difference. So all you do is you take the price of Hampton, subtract to La Quinta to get 129, subtract 105 to get 24. The same thing for the other nice data. So we subtract the differences between them to get the D. And now 24, 53, 140, 10, and so on. This is the value for D. Now you have to check that, make sure that this D data is coming from a population having a distribution that is approximately normal. Well, you can do this. The first thing is you can use the normal quantile plot to check for the normality. Now the first thing is we have to input the column D into the list L1. So go ahead and click the start and edit. Okay, so we click the start and then we enter edit, and then the L1 here we enter all the number of 24, 53, 100 into the column of L1, and now we hit the second start plot, right, to get to the start plot. So second, the blue one get you to the start plot. So second start plot, so get you to the plus one. Make sure you turn on the plus one. Okay, so enter the plus one. We turn it on. We pick the last option. This is the normal quantile plot, and then we use the data axis to be X, and the data list, make sure you use correct L1 because we store the data to L1, and then just go to zoom in here, zoom, and then select the zoom start, and it will plot you the data. And we can say this is a good linear straight line, and there's no violation of the normality assumptions. Therefore, we can conclude that this requirement is okay, right? It's approximately normal for the populations because of the linear pattern, the straight line. Okay, so we asked to do to test the claim that the price are different. That means we use the different size, right? The equal with the dash. So, and this is the two tails, and the mean for the differences should be 0 for the null hypothesis, If not 0, then they are different. Then that becomes the alternative hypothesis. And this is the two tails, of course. Alpha is given as 0.05. Now we need the D bar and the SD for the test statistic formula. D bar is just the mean value of all the differences that you just found in this column. So this is the D column. D bar, you just add all of them together, divide by 10 to get the mean value. Then we can also find the standard deviation of those differences for all the 10 values of D. And we can do that easily just by going to the stat calculate and one variance stats. So go out here, go to the quit, start, move to calculate, and choose the one variance stats. Okay, and then you just have to enter the list one. Make sure the list one is the data you store here for the D, right? So make sure you use the correct L1, and then hit the calculate button and hit enter. Okay, so one variance stats give you, this is the mean, and the mean here is the mean for the D, because we use the D column. So this is the mean for the D column. And then S is the capital S is the standard deviation, or this is the standard deviation of the D, the column D. And once you get the D bar and SD, we can find the test statistic. T0 is D bar over SD divided by N, the square root of N. And we know that we have 10 pairs, so divide by square root of 10. And T0 should be 6.30. We know this is two tails, so T0, this is the positive value, so we label it here. And all you do is you have to find the area of this right tail and multiply that by 2 to get all of them, the sum. Okay, so this is the T distribution. So we use the TCDF. This is the cumulative area under the curve from the test statistic T0. The input for the lower bound, we go from the T0 6.30. The upper, we go all the way to the right, 10 to the 99. And then the derivative freedom is n minus 1. We have 10 pairs, so 10 minus 1. And multiply that by 2 using the TCDF. Recall that if you want to get to TCDF, go second distributions here. And then just move the cursor to TCDF and then enter. Okay. We got 0.00141 for p-value, and this is less than 0.05, which is the level of significance. If it's less than alpha, then we reject the null hypothesis H0. Let's try the critical value and see if we do end up with the same value or not. Okay, the same conclusion. We are given alpha to be 0.05. This is the area for the tails, but this is the two-tail case. So therefore, you have to divide the alpha into alpha over 2 here, and then another alpha over 2 here. We know that this is the area. We are given the area. Now we want to find back what is the value for the critical value. So you have to find the inverse of that T statistic. And the commands of the T are 84, 83. You take the input of the area to the left of that critical value. We know that this is 0.025, so the whole thing is 1. So 1 subtract this portion gives you the left area of this critical value. So let's take the input of the area to the left of that critical value, and then comma the degree of freedom. Let's give me 2.262. And this value, the critical value, 2.262. And go back to the test statistic. 6.30. 2.262 is right here, but the test statistic is 6.30. This is way above 2.262. That means to the right of 2.262, or the test statistic is inside the critical region. Then you reject the null hypothesis. If it's inside the critical region, you reject it. If it's outside, you do not reject. So we do end up with the same conclusion, reject the null hypothesis in the two methods, the critical value and the p-value methods. So if you reject the null hypothesis, that means go back to here. We do not support this one. Okay, that means we say the mean for the differences should be non-zero, right? If it's not zero, that means they should not be equal, because if they are if the prices are the same, then when you subtract them, you should end up with zero. But now we do not support this claim. We fail to reject it, right? We fail to we reject the null hypothesis. That means we focus on this alternative hypothesis, or the means of the differences should not be zero, or the prices should not be the same. If the prices are the same, then you should support the null hypothesis, because when you subtract them, when you subtract two same things, they should end up with zero. But now, because we don't support this, guys, so that means the prices should be different. Or you can conclude that there's sufficient evidence to conclude that the prices for the Hamptons and the hotel are priced differently at the level of significant alpha equals 0.05. We can also construct the confidence interval regarding the difference of the two dependent means. This should be dependence. Sorry for the typo. Okay, and this is the formula. Again, we use the d bar, the critical value, SD, and the square root of n. Now, use the same data from the previous example. Construct a 95% confidence interval for the mean difference in the price between the Hampton and the La Quinta. We had all the value, d bar, SD, and t alpha over 2. So we can just find the lower bound from this formula and the upper bound from this formula given here. And then it gives me the confidence interval of 34.23 and 72.56. So we are 95% confident that the mean difference in the hotel room price for the Hampton versus La Quinta is between this price and this price. Okay, so the last objective for this videos is to use the technology TI-83 and 84. We use the same data, the same example for the Hampton and La Quinta, but now we only use the TI-84 and 83 to make the conclusion. Okay, so we know that the null hypothesis and the alternative hypothesis, they are the same thing as before. The mean of the differences, we claim we assume it to be 0 for the null, and we assume is not equal to 0 for the alternative hypothesis. In this case, you have to load the data for the Hampton to L1, and then for La Quinta to the column L2. So make sure enter all the prices for L1 for the Hampton and La Quinta for L2. And it's the same way. We just use the TI, go to Start, Edit, and then just enter column L1 and L2 for the two prices. Right. Okay. So the reason we enter here, because we can use the column L3 to find the D, which is the differences between the 2 points. Now before, remember that we did the calculation by hands. We subtract 129, subtract 105. We did all of them by hand. But if you have a large set of data, it's very time consuming to do this by hand. It's the best way is that you just enter all of them to column L1, column L2, and then use the column L3 to find the difference between L1 and L2. They would do the subtraction for you all. Okay, so we store the data to L1 and L2. Now, how do we find the subtraction between them? Well, you move the cursor, sorry, not the arrow, the cursor to L3, and then you hit the enter. Once you hit the enter, you just type L1 subtract L2. Okay, you want to find the difference for L1 and L2 and store them in L3. So hit L1 subtract L2 as the location of L3. So just move the cursor to up to L3 and then hit the enter. And here you're just gonna type L1 is this blue button right here, so you have to use a second L1 subtract second L2 to get the L2 letters. So L1 subtract L2 and it just hit enter, because I did not have any data points here, that's why I got the errors. But once you do that, you should be able to get the column L3 for the D, the little d. Okay, so once you have the D, we can perform the t-test on this column, this data, because this is the student t distribution, so we can use the t-test. Now press start and you go to the test and choose the t-test. So again, start and right arrow to test, and then pick the t-test. This is the t distribution, so use the t-test. Once you hit the t-test, you see that we have two options. Either we use the data or we use the stats, the statistic. But we have the data here. We have the data stored in L3. Therefore, you pick the option for data, and we assume that the mu is 0. The mean of the differences is 0. We assume it's here to be 0, so that's why we put 0 here. The list, we pick the column for the differences, L3. Frequency is 1, and this is the alternative hypothesis. We assume that they are not equal. They are not equal. They are different, so the different size. Okay, and then hit the calculate, and then it will give you t here is for t naught or the test statistic. This p here is the p-value, and we can see that this p-value is less than alpha. So we reject the null hypothesis, which is the same conclusion that you saw earlier. We reject the null hypothesis here. Okay. All right. So we can also use the TI-83 or 84 to do the to find a confidence interval. It's very simple. Just go to the start test again, but in this case, in this time, you pick the t interval. This represents for the confidence interval of the t distribution. So hit the enter here, and then again we use the data. We store the data in the list, the column L3. So just enter that. The confidence level, we are asked to find the 95% confidence level. So that is equivalent to 0.95 in decimal. And then hit the calculate, and you get the lower bound and the upper bound, 34.234, 72.566, and this should be, yes, the same thing. Okay, so we are 95% confident that the mean difference in hotel room price for Hampton versus La Quinta is between $34.23 and $72.56. So that's how you use the TI-83 or 84 to perform the test to find the p-value and the confidence interval. That's why I mentioned before the p-value is the common one, because the technology is give you the p-value instead of the critical value. Okay, so that is the end of this section, and thanks for watching.